welcome to today's class. Today we are going to discuss chapter number 8, applications of integrals. The first section is area under simple curves. Area under simple curves. Suppose y is equal to f of x is our curve and we need to find out the area under the curve y is equal to f of x from x is equal to a to x is equal to b. X is equal to a to x is equal to b. We need to find out the area under the curve y is equal to f of x. Here we are going to do integration. That before integration, actually we can divide these areas into some small strips. Okay, we can divide this a portion, that shaded portions, into thin strips. Then that arbitrary strips, here I am going to consider one arbitrary strip. This is my arbitrary strip with height y and this width dx. Okay, this is my arbitrary strip in the shaded region with the height y and breadth dx. Then we know that that strip is in the form of a rectangle. So the area of that strip that I am going to represent it by dA. dA is equal to y into dx. dA is equal to y into dx. Then this y that we know that y is equal to f of x. This area is called the elementary area. Okay, this area is called the elementary area, which is located at an arbitrary position within the region which is specified by some value of x between a and b. Okay, actually this arbitrary strip, that is a strip inside, the shaded region. The shaded region, we can divide the shaded region into infinitely many small thin strips. Okay, and we know how to find out the area of that thin strips, because that thin strips will be in the form of a rectangle. The area of a rectangle is length into breadth, and here I am going to consider one arbitrary strip with a length y and breadth dx. Then the area dA is equal to y into dx, and this area is called the elementary area. Okay, now suppose we need to get the area of that shaded region. In that shaded region, if the axis varies from A to B, in that shaded region, axis varies from A to B. So by integration, the area of that shaded region, capital A, is equal to integral A to B y dx. Integral A to B y dx. And what is this y? Y is equal to f of x. So integral A to B f of x dx. Integral A to B f of x dx. Here the integration is with respect to x. So this interval of integration, that is also the variation of x. The interval of integration, you should write the variation of x if you are doing the integration with respect to x. We have one more formula, that is a is equal to integral c to d g of y dy. Integral c to d g of y dy. What is the speciality of the second formula? In second formula, we are doing this integration with respect to y. So this function here, that should be in terms of y, and this interval of integration, that should be the interval of integration corresponding to y. So area under simple curves, either we can find out the area under simple curves by using the interval of integration of x or the interval of integration of y. Now we have some special cases. Suppose if the position of the curve under consideration is below the x-axis. Suppose the position of the curve under consideration is below the x-axis. That means, suppose our curve is, this is our portion. We need to find out the area of this shaded region. This is x is equal to a, and here it is x is equal to b, and this is our y is equal to f of x. Okay, now just look at this figure. Here the area under consideration is below the x-axis. Area under consideration is below the x-axis. Then the area corresponding to this we will get a negative value. Okay, if you integrate integral a to b f of x dx, integral a to b f of x dx will give the area under the curve y is equal to f of x from a to b. Right, now since it lies below the x-axis, you will get a negative value for this integral a to b f of x dx. But we know that this area is a positive quantity. So what we want to do is, in this case, we need to take modulus. In this case, we need to take modulus. If the area under consideration lies below the x-axis, you need to take the numerical value of that integral. You need to take the numerical value of that integral. Absolute value of that integral we need to take. Now, one more case. Suppose we have two portions. Suppose we have two portions. Okay. So this is our portion. Now just look at the shaded region. The first one, let it be A1, and the second one is A2. What is the speciality of this? A1 that lies below the x-axis and A2 lies above the x-axis. A1 lies below the x-axis and A2 lies above the x-axis. So in this case, A1 that represents the area, A1 that represents the area of the shaded region which lies below the x-axis, and A2 represents the area of the shaded region which lies above the x-axis. Then the total area, that is, since this A1 is A1 is the value of the area which lies below the x-axis, then that A1 should be negative. So here we need to take modulus A1. Absolute value of A1 plus A2. Absolute value of A1 plus A2 will give the area of that shaded region. So, the area under the simple curve, let y is equal to f of x, that is our curve, and we need to find out the area of this shaded region from a to b. Then we are doing integral a to b f of x dx, and this integration we can do with respect to y also, but in that case you need to write the interval of integration corresponding to y instead of the integral of integration of x. That is the only difference. And we have two cases. One, suppose your area lies below the x-axis, then obviously the integral will give a negative value. The integral a to b, if it is integral a to b f of x dx will be a negative value, and we know that the area is always a positive quantity. So what we want to do is we need to take the absolute value of that integral if the shaded region lies below the x-axis. And the second one is the combination of that two. One portion lies below the x-axis and the one portion lies above the x-axis. Then the sum of these two areas will give the area of that entire portion. So for that, the first one, A1, that is the area corresponding to the portion which lies below the x-axis. In that case, you need to take the absolute value plus A2 will give the area of that shaded portion.